Hello friends, today's question: an ideal gas is expanding such that Pt square is constant. The coefficient of volume expansion of the gas is given as. So we have to find out the coefficient of volume expansion, that is our beta, in terms of temperature. So in this case we are going to use the standard formula for volume expansion, which is beta is equal to 1 upon V, partial derivative of V with respect to temperature. And then we are going to use the equation for the, rather we can say ideal gas equation, and solve them further together, and that is going to give us the relationship between the volume and the temperature. So we start with the standard formula, that coefficient of volume expansion which is denoted as beta, and this beta is given as 1 upon V, partial derivative of V with respect to temperature, where V is the volume of the gas and T is the temperature. Volume of gas and T is the temperature. And we also know that for ideal gas, or which is our ideal gas equation, we have PV is equal to nRT. Here N is the number of moles, R is the gas constant, P is the pressure. Here we have N as number of moles, R is our universal gas constant, and P is the pressure. V and T we have already defined it. V is the volume and T is the temperature. And we are also given that pressure and temperature square, it is given as a constant. So let us assume that constant is given as K, and from here we can find out, we can rather write P is equal to constant K divided by T square. So we substitute this value of, let us call this equation as 1, this equation as 2 and 3. So using equation 2 and 3, we replace the value of P, pressure, in equation 2. Using equation 2 and 3, we can write K upon T square multiplied by V is equal to nRT, and this gives us that our volume V will be equal to nR upon K multiplied by T cube. And we are going to now partially derivate it with respect to temperature T. This gives us partial derivative of volume V with respect to temperature T. It will be coming as N R upon K, all these are constant, so this will be coming as 3T square. And we are going to substitute this value of partial derivative of volume in equation 1. So we can say, using equation 1, we get beta is equal to 1 upon V and partial derivative of nr 3t cube. So let me also substitute the value of v. So we get this as 1 upon nr t k multiplied by, we have this nr k multiplied by 3t square. And here most of the terms are going to cancel out, k with k, nr with nr, and this t cancel with this t square. Sorry, 1 second. Yeah, it's t cube, my mistake. This is t cube, not. So we can write this as 1 upon nrk, and this is our t cube, multiplied by nrk, and this is our 3t square. Now it's correct. So this come cancel, a square goes with this entirely, and we are left with 3 upon t. So we get beta, that the coefficient of volumetric expansion is equal to 3 by t. And the options that are given to us, option number C is correct one. You can say option C is correct. C is correct. So this completes the question. Thank you.